Welcome to Race MES. Today, I'm excited to introduce you to our AI-first execution layer for manufacturing, which encompasses rule, action, cognition, and events. This innovative system senses, decides, acts, and learns in real time.
Let us begin promptly with the data sources.
Connection Sources serves as a key hub for integrating data, in this case the Aveva data source. The Race platform allows for the configuration of multiple tenants and namespaces, ensuring secure management of client IDs and keys for production assets. It enhances operational efficiency by streamlining data ingress for continuous monitoring, analysis, and real-time asset tracking.
Race searches for assets and streams, allowing the user to select which ones they wish to monitor.
In asset management, Race has pinpointed 46 assets that are prepared for connection. For this specific use case, we have chosen Wonderbrew, an asset that simulates data for a beer factory. This asset has been selected for the monitoring cycle and is now set to explore 546 streams for possible connections. Race provides an overview of all available streams, enabling users to select specific ones for monitoring. With the Smart Search filter, you can easily navigate through an extensive array of data points, allowing you to focus solely on your needs. Currently, 40 streams were integrated into the monitoring system. To illustrate its user-friendliness, we will add an additional stream by clicking on Plus Monitor. The default scan cycle is set to every 30 seconds, but it can be adjusted as needed. Once you have added the enabled streams to the monitoring engine, you can access the stream monitoring page to verify their status, quality, and the values that should correspond with the various sources. In this live example, you can observe how the data is accurately mirrored from the Aveva data source.
The Rule Engine is a versatile framework for defining universally applicable logic, organizing rules by business domain with reusable templates.
This document outlines the rule management configuration, which is designed to establish logic once and apply it universally across various contexts. Packages are organized by specific business domains. For instance, we have developed packages for manufacturing operations, energy management, and safety. These packages are released periodically, allowing us to create as many as necessary to align with business priorities and market demands. Templates serve as encapsulated reusable patterns with placeholders, each mapped for runtime execution to corresponding monitored data points. Notably, templates can be utilized within the Race Lightweight framework, which operates on premises to ensure business continuity for critical operations. Within these templates reside rules. Each rule defines conditions, severity, categories, and optional contextual enrichment, all while incorporating built-in auditing and versioning capabilities. When a rule's conditions are met, it generates an event, enhanced by additional contextual data provided through the variable enrichments. This mechanism facilitates advanced analysis powered by artificial intelligence. The rule management system is AI-assisted. By entering your requirements in natural language, you can receive proposed conditions that can be validated against your specific business needs. When rules are updated, all related placeholders appear in the editing section, ensuring comprehensive source coverage. This integration enhances governance and operational efficiency within a unified solution.
Here we bind reusable templates to the ISA 95 plant model to create governed instances.
This is the plant model, our ISA 95 digital backbone. For this beer factory use case, we map enterprise, site, area, line, unit. Each node is typed and carries authoritative IDs and context. At any node we can deploy a template, bind placeholders to live streams, and enrich events with contextual data, all under instance-level governance. That context travels with every event, enabling traceability, multi-site reuse, and low-latency routing. At any node of the plant model, we instantiate a template. The instance is the contextualized version. Placeholders are bound to live monitored streams and optional enrichment. This enables safe reuse of the same template across sites, levels, and equipment, with consistent governance and audit. Creating an instance is fast and intuitive. Select the plant model node, click Create Instance, choose the package and template, and assign a unique function location ID, flock. Then bind the template's placeholders to the live monitored streams, and you're done. This workflow scales across nodes, letting you map an entire factory in minutes with consistent governance and audit. Once all instances are mapped, simply click Deploy. The instance moves into a governed runtime state. The rule engine subscribes to its bound streams and evaluates conditions in real time. When conditions are met, traceable events are generated on the event wall and can drive downstream actions immediately. For instant oversight of deployed instances, Open Instance Monitoring. It provides a real-time summary of each instance executed by the rule engine, status, last trigger, recent executions.
Event is the heartbeat of race. Every rule hit becomes a timestamped, categorized event enriched with context data.
The event wall is the operational heartbeat of race. It's a live, scrolling timeline where every rule hit becomes a timestamped, categorized event enriched with plant context from the ISA 95 model. Color and icons signal severity and category, production, maintenance, quality, utilization, so you spot what matters at a glance. This real-time KPI bar gives us instant situational awareness. Frequency shows event throughput. Critical percent tracks high-severity hits. Patterns counts distinct event signatures. Effectiveness is our configurable metric, e.g., the share of events actioned or resolved within SLA. Live streams indicates active signals under watch, and response is the latency from stream update to event. The event duration summary breaks down time by template, highlighting where to investigate and optimize. Combined with time range controls and powerful filters by template, rule, category, and severity, these KPIs turn the event wall into a strategic analysis surface. In seconds you can slice across lines and assets, spot bottlenecks, correlate spikes, and zero in on root causes. And because it's all real-time, insights translate directly into action. From rule configuration, we design the event wall experience end-to-end. Set colors by category and criticality, choose the fields shown on the cards, define mappings, correspondences, and add calculations like duration, deltas, and moving averages. The hero is enrichment. With a single binding you can bring context from anywhere, ERP, Factory DB, LIMS, CMMS, quality systems, even external APIs, and attach it to each event the instant it fires. Order ID, product, batch, shift, work center, operator nodes, all travel with the event, searchable and filterable. This turns a raw trigger into a complete operational story you can analyze directly on the wall, across assets, time ranges, and filters, to expose bottlenecks, link causes to effects, and move from insight to action in real time. Select any event and the console deep links you into event management. Here we correct reality safely. In this example, an undeploy-deploy cycle created a gap on the fermentation tank. The operator patched it directly. If something needs rectifying, Race lets you fix, as recorded, to match, as occurred, quickly, compliantly, and with complete traceability. We can edit start, stop times, trim, split, or merge events, reclassify them, and manage full enrichment, reason codes, product, batch, shift, operator notes, and more. Every change is governed and audited. Version history, who, when, what, with recalculated duration and metrics so downstream dashboards and analyses stay consistent.
This is where events become outcomes. The Action Engine orchestrates real-time workflows, alerts, API calls, microservices, governed, reliable, traceable.
An action is a generic function, typed inputs in, outputs out. Under the hood it calls a microservice, from a simple notification or email, to a compute task, an ERP integration, or a slice of MES process logic. An action consumes a microservice over a REST API. We support standard methods, get, post, put, with TLS, OAuth 2 and signed headers as needed. Inputs are passed as query parameters or post body fields. The service returns a JSON payload that we map back into local placeholders for downstream use and audit. In this example, the action is configured to send a notification. Race calls the REST endpoint, passes the event fields and enrichment to the function, and the microservice delivers the message to the operator in response to the triggering event. Simple to configure, governed, and fully traceable. In this first example, we bind an action to a safety risk event when the fermentation tank level crosses a defined threshold. That condition represents a hazard for the area and operators, so the action emails the supervisor immediately. We pass the current level, tank type, and optionally location and severity as parameters. The action calls the REST microservice, which sends the notification and returns a JSON receipt. You'll see the call execute, the message delivered, and the result logged back into the event trail for full traceability. In the second scenario, we raise the complexity to stress test the prototype. We simulate process order start, a core manufacturing execution moment. On PO start, an action calls a microservice to generate a lot code. When the lot code returns, it emits a new event that triggers a second action, a microservice to download parameters to the PLC. This is an event-driven workflow. One event produces data, the next consumes it. We pass PO, product, and equipment as inputs. The lot code comes back in JSON and is bound to placeholders for the downstream call. The chain runs with correlation IDs, retries, and audit, so you see end-to-end traceability. From order start to PLC parameterization, executed in real time. On the event wall you see the entire workflow execute end-to-end, PO start, lot code generated, PLC parameters downloaded, correlated as a single chain. Every step is timestamped, categorized, and enriched, so in one pane of glass you gain real-time situational awareness across assets and systems. Severity cues, context, and a full audit trail make it both actionable and defensible. You know what happened, where, and why, right now. That's the difference. From scattered logs to an operational source of truth you can trust and act on instantly. Drowning in thousands of rules, actions, and variables? Meet the Workflow Visualizer, an interactive map of your runtime. From the triggering event to every downstream action, watch the flow as a living graph. Hover to reveal inputs and outputs, loops, dead ends, and bottlenecks. Filter by package or template to see an exact map of which rules executed, which actions fired, and which events were produced. With one click you pivot into detailed views for rules, events, and actions. Run impact analysis. If I change this workflow, what result will I get? With version tags and full audit at every step. It turns complexity into clarity and curiosity into control, so you can go from why to what next in seconds.
Here we meet Race AI, data control, assistance, agentic missions, and prediction.
With the Race MES system we can configure mainstream AI providers and decide how they operate. We spin up chat endpoints that work with our data, rules, and actions, define assistants with precise instructions in a constrained system prompt, and register agents we can send on missions with the right tools and policies. In this demo we're using OpenAI and Gemini, but the connector is provider agnostic, local or cloud, public or private models. Everything runs under governance, credentials, rate limits, logging, and safety controls. In short, we choose the model, we control the behavior, and we keep the intelligence inside our operational flow. Let's take a quick look at configuration. Select the provider and model, add your instructions in system prompt with guardrails, and then run a built-in test to validate responses before going live. Let's start with Race AI's first capability, data control, powered here by a standard GPT model. We can configure multiple chat endpoints and expose them in the contextual menu. I'm opening chat with my MES data. All MES facts are pre-serialized and AI-friendly, assets, streams, templates, instances, events with enrichment, and KPI snapshots, so the assistant can reason over governed data without SQL or ad hoc scripts. The chat runs under guardrails. A scope system prompt limits topics and actions, provider and model are selectable, and responses are grounded on our plant model and event wall, not on the open web. Credentials, PE, and secrets are masked. Every exchange is logged and auditable. Let's ask, what's the current state of the fermentation line? The assistant composes a clear answer, cites the latest stream values and events, and highlights anomalies. It proposes actionable suggestions, for example, investigate process order start due to a PLC connection error, and review utilization. Roster 22 where repeated hold on events extend cycle time. Follow-ups are natural. Show last 24 hours holds and top reasons. It returns a ranked summary with durations and affected equipment. What changed after the last PO start? It correlates a longer ramp-up and flags upstream temperature variability as a probable cause. Most importantly, chat is not a dead end. Suggested actions can open an action pre-filled with parameters, or create a cognition mission for deeper investigation, keeping the operator in one flow. In short, data control turns natural language into a governed control surface over MES data, surfacing issues, explaining context, and proposing next best actions in seconds. Now let's talk about the assistant and how it differs from GPT chat. With chat, we expose governed MES data to a model: events, the plant model, context, and enrichment. You ask questions, it reasons over what it understands. The assistant goes further on for context, investigation, analysis, report, or troubleshooting, about assets, rules, actions, and events. It's specialized and mission-oriented. I can spin up as many assistants as I need and scope each one tightly to a specific equipment, a process area, or even a safety scenario. Each assistant carries its own instructions, permissions, and guardrails. Critically, an assistant has tools, and tool usage can be enforced by policy based on the request. If I ask for an investigation, it must run the log inspector, correlate recent events, and check rule executions before answering. If I ask for a report, it must use the charting report generator to return structured visuals, not free-form text. For safety workflows, it can be required to run the checklist and notification tools before it considers the task done. Let's do exactly that. First, I request an investigation. The assistant gathers the last hour of events, inspects system logs, correlates with the plant model, and returns a concise root cause hypothesis with next best actions. Then I ask for a report. It builds the graphics from the governed data model, charts, tables, and a short narrative. In this demo, we're using simulator data, so treat values accordingly. The flow is identical with production data. The result is a step beyond Q&A. Assistants turn intent into governed, tool-driven workflows, repeatable, auditable, and aligned to the way we actually run the plant. Now, the standout: agents. Unlike assistants, which use tools when you prompt them, an agent is mission-driven and autonomous. You define the mission, scope, permissions, and a toolbox. The agent decides which tools to use, when, and how to combine them. It runs a plan, execute, evaluate loop, queries governed data, correlates events, calls microservices, and, if allowed, triggers actions. You can launch it manually, on schedule, or on event. It reports back with evidence, KPIs, and recommendations, fully audited with correlation IDs. Guardrails, policies, rate limits, timeouts, and optional human checkpoints keep it safe. In short, assistants answer, agents deliver outcomes. Let's finish with a look ahead. Event prediction in Race MES. Using AI, we ingest historical events over a chosen time window and forecast what is likely to happen in the next hours, or any horizon you select. This is powerful for safety, prevent hazards, execution, avoid scrap or unplanned stops, and energy, curb runaway consumption. The model learns recurring patterns across millions of signals and events, then outputs a ranked list of expected events, each with confidence, time to hit, and leading indicators. You can run it on demand or on schedule, and every prediction carries traceability: what data it used, why it believes a spike is coming, and which assets are implicated. Predictions don't sit on a dashboard, they flow into actions, preemptive alerts, parameter adjustments, or operator checklists. It's not a black box, it's a governed, auditable service that turns hindsight into foresight, so we can anticipate, mitigate, and protect before issues materialize. That's the future Race enables. Thank you for your time and attention. With Race, we turn raw signals into decisions, actions, and learning, in minutes, not months. We've shown how rules, actions, cognition, and events come together to deliver real-time visibility, governed workflows, and AI that investigates, acts, and predicts. Thank you.